Welcome to This Explainer. Today, we're taking an absolutely epic journey. We're going to scale all the way up from our immediate earthly anxieties, right to the literal end of the universe. You know, it is so easy to get bogged down in the day-to-day crises we face, but we designed this to completely shift your perspective. We're going to explore exactly how humanity can survive its current growing pains, engineer our home planet, colonize the stars, and eventually witness the final fading moments of the cosmos itself. So get ready to stretch your imagination.
Okay, let's dive into this. It's incredibly common for every single generation to assume they're important enough to witness the apocalypse. I mean, rapid climate change, the explosive rise of AI, intense global political division, all of this makes it kind of hard to look at our species with optimism right now. But are we really in the end times? This kind of short-term pessimism actually prevents us from creating the best world for our descendants. When we frame humanity's current struggles against the vast, staggering scale of cosmic time, we realize that we're really just at the very beginning of our story. But obviously, to see that future, we have to survive our present. Section 1. Escaping the Great Filter. So this is the first major hurdle humanity faces if we want to survive into the deep future. To reach all those cosmic wonders waiting for us, we absolutely must pass through what astrophysicists call the Great Filter. It's basically a theoretical barrier of incredibly hard steps that prevent civilizations from advancing and spreading across the universe. And the stakes here are dramatic. Think about our current technological adolescence. We have thousands of nuclear weapons just kicking around. We have fossil-fueled climate change threatening our entire biosphere. And we are right on the verge of creating artificial general intelligence. If we create a misaligned AI that wipes us out, or if we trigger total ecological collapse, well, we get filtered out. We never become a multiplanetary species. But on the flip side, if we make the right choices today, like engineering our planet to survive climate collapse and building AI with the proper guardrails, we can safely navigate this bottleneck. Section 2. Engineering our planet. Moving past simply surviving, we eventually arrive at the need to take proactive, incredible control over Earth's natural systems to build a safer home. We live on a highly dynamic planet where a supervolcano, like Mount Toba, could erupt and potentially claim up to 1 billion lives. It is a massive existential threat. But instead of just waiting around for the inevitable, what if we engineered a solution? Well, one brilliant proposal from a NASA engineer actually involves drilling boreholes deep around a magma chamber. By injecting cold water down there and extracting superheated water, we not only gradually cool the sleeping beast over tens of thousands of years to prevent an eruption, but we also secure a continuous source of renewable geothermal energy. We can literally turn a planetary threat into our salvation. And this brilliantly illustrates just how massive and fast-paced our ideas need to be. To stabilize our climate, we might need some radical geoengineering. To cool the planet, we could act like artificial volcanoes, spraying stratospheric sulfur dioxide to reflect sunlight, basically like a giant planetary sunscreen. Or, get this, as MIT researchers proposed, we could build a solar shield out in space made of silicon bubbles roughly the size of Brazil. Back here on Earth, we could deploy mechanical trees, where just a single one sequesters 1,000 times more carbon than a real living tree. We even have these incredibly bold plans to build a 100-kilometer underwater curtain to block warm ocean currents from collapsing the massive Thwaites Glacier down in Antarctica. Managing our planet is for sure going to require profound technological alliances with the Earth's natural systems. Section 3. The Kardashev Steel. Now, as we master our planet and our energy needs grow exponentially, we begin to climb an incredible ladder of civilization. Any guesses on where we are right now? Our current cosmic report card sits at just 0.73. Developed by astrophysicist Nikolai Kardashev, this scale measures a civilization's advancement based entirely on its energy consumption. Despite all our smartphones and international space stations, we haven't even reached a Type 1 status yet. We still rely heavily on burning dead plants, fossil fuels, for energy. However, with massive breakthroughs in artificial intelligence and nuclear fusion, we could rapidly accelerate our status within just the next few centuries. Let's actually walk up this ladder and look at how humanity scales up. Step 1 is a Type 1 civilization, which has complete control over its home planet, harnessing absolutely all of its solar, geothermal, and wind energy, and even controlling the weather and earthquakes. Step 2 requires a huge leap. A Type 2 civilization harnesses all the energy radiated by its home star, giving them virtually infinite power to go out and terraform other planets. Finally, Step 3 is a Type 3 civilization, which spans out to harness the energy of tens of billions of stars across its entire home galaxy. It's a complete evolution, from earthbound to stellar to truly galactic. Section 4. Settling New Worlds. But of course, to get to Type 2, we have to leave the nest, and our journey into the cosmos starts right next door. I want you to imagine yourself in the year 2126, living in Luna Prime. This is a totally self-sustaining moon city near the Shackleton crater, down at the lunar South Pole. Because there's almost constant sunlight there, massive solar panels provide uninterrupted power, and those deep, permanently shadowed craters hold absolutely precious water ice. Just imagine donning a spacesuit to go check on 95-year-old radioactive plutonium heaters in those frigid craters, and then returning to your home inside massive domes that were 3D printed right out of the lunar soil, the regolith. Luna Prime will be humanity's crucial stepping stone. It's our gateway to the rest of the solar system, making rocket launches 84% easier just thanks to the low gravity.
Now, what's really interesting here is comparing the bizarre, sometimes hostile, yet promising alien worlds we might one day inhabit beyond our solar system. Proxima b is our closest neighbor, at over 4 light-years away, but it's tidally locked to a highly volatile red dwarf star. Half the planet literally boils, while the other half freezes solid, meaning settlers would have to live in this narrow strip of perpetual twilight called the Terminator Zone. Then there's TRAPPIST-1e, 40 light-years out, which gives us hope for liquid water under a dim, eternal sunset. And K218b, a massive 120 light-years away, might be an ocean-covered super-Earth, where we'd have to engineer hovering cloud cities just to survive the crushing atmospheric pressures.
To travel to these distant worlds, we are going to need an unfathomable amount of energy. 400 septillion watts. Let that sink in for a second. That is the jaw-dropping amount of energy we would capture if we built a Dyson swarm, a massive array of millions of solar collectors orbiting our sun. To put that into perspective, it's 1 trillion times more power than our entire civilization consumes today. To build it, we might literally have to disassemble the entire planet Mercury just for the raw materials. But the payoff? Absolute energetic mastery of our solar system. Section 5, the end of time. Because even stars have an expiration date. Let's move on and see how this builds, because we are going to fast forward exponentially now, billions and trillions of years past the era of human cosmic engineering, straight into the unfathomable deep future. Our universe has a life cycle. In about 5 billion years, our sun will run out of fuel, expand into a red giant, and completely consume the Earth. But that's just our local neighborhood. Look further down the timeline. In 100 trillion years, the universe will simply stop forming new stars. The lights will slowly go out. By 100 quintillion years, the glowing remnants of dead stars, white dwarfs, will cool completely into dense, dark ashes called black dwarfs. And in 10 to the 40th power years, scientists predict that protons themselves will decay. All ordinary atomic matter will literally fall apart and disintegrate into nothingness. So, what is left after matter decays? Welcome to the black hole era. There will be no planets, no stars, no life as we currently understand it. It will be a beautifully bleak, silent, and nearly motionless era. The only major events in this incredibly dark void will be the occasional mergers of supermassive black holes, sending powerful gravitational waves rippling through the fabric of space-time, ringing out like distant cosmic bells. It is a stunning, almost poetic contrast to the hyperactive, vibrant era of civilization we are living in right now. But incredibly, even black holes are not immortal. Through a quantum mechanical process called Hawking radiation, black holes will slowly leak energy and evaporate. Eventually, the very last massive black hole will evaporate in a final flash of light. After that, the universe becomes nothing more than a vast sea of cooling photons, stretching out as the universe expands, dropping infinitely toward absolute zero. At this point, entropy reaches its absolute maximum. The cosmos simply cannot get any more disordered. And because there are no events left to measure one moment against another, time itself becomes completely and utterly meaningless. Nothing happens, and it just keeps not happening. Forever. Faced with the ultimate icy death of the cosmos, Helen Keller's words resonate perfectly here. Everything has its wonders, even darkness and silence. It directly connects the grand, unimaginable end of everything back to the resilience of the human spirit. Even in the face of absolute darkness, there is awe. Knowing the ultimate fate of the universe doesn't render our present meaningless at all. Actually, scratch that, it does the exact opposite. It highlights how incredibly precious and rare this brief window of light, warmth, and life truly is. Which brings us to our final thought today. The universe has given us an incredibly brief, bright haven in time. The choices we make today to safely navigate AI, to protect our fragile climate, to look up and reach for the stars. These are the very first steps on a path that could stretch out for trillions of years. Will we be the generation that overcomes our short-termism and sets humanity on the path to the end of time? I really hope this explainer has sparked your curiosity and expanded your horizon today. Thank you so much for joining me on this journey, and as always, keep looking up.